What's going on, guys? Welcome back. So today we're going to go ahead and talk about the software delivery lifecycle pipeline. And this is just a good conceptual framework to have an understanding of. We're going to walk through it step by step so you guys can have, again, a holistic understanding of how highly available and useful software is delivered to end users. So essentially here on the far left we have ideation. That's the first idea, that's your spark that is designed, that is the product. Then you have product management, which is essentially the product managers that essentially work with the dev team to translate the business requirements into business logic, which is the code that makes up the system itself, makes up the product itself. And then we have testing and QA, and that's so once we translate the English into business logic, you have testing and QA teams, which essentially assess the quality of the code itself, whether it adheres to various security standards, whether it's semantically consistent or syntactically consistent, we'll say, whether the documentation standards are there, a whole litany of things, essentially. And we see this arrow here. This is called the Agile arrow in blue, but this is what Agile solves. So Agile is a methodology for essentially quickly, fast, iterative improvements in translating English to code to tested code, essentially, and keeping that loop, that feedback loop, fast and accurate. So next up here we'll talk about another feedback loop, and that is the DevOps feedback loop. So again, DevOps is a broad thing. It's a huge set of principles, essentially, that are applied quite uniquely in a variety of contextual situations. But essentially here we have development, testing and QA, and then the push to production. And that's essentially what DevOps aims to extract efficiency, or we'll say maximize efficiency in. So that's with things like, again, CI/CD pipelines, essentially being able to automate as much as possible between the development of the code and the push of that code to a production environment. So what's interesting here is if we invert these arrows. So what if we took an arrow and we draw it starting with the customer? I hope my face doesn't blot that out. See if I can. Yeah, so here we go. Maybe you guys can see that better. So if we started starting with the customer there, and then we went ahead and we walked all the way back thinking, okay, how do we maximize efficiency with the customer in mind? Then you run into something different. Then you run into things that the customer wants. So as a customer of or end user of a software product, or even a system consuming another system, what are the most important qualities? And those qualities are reliability and availability. We'll take, for example, would you rather use Gmail with all the latest features but it's down, or Gmail with none of the latest features but it's up? Which one are you going to use? If you use Gmail to send email, which one are you going to use? Which one is going to make you happy? Which one's going to promote trust? Which one is going to essentially feel like the company is looking out for you and is actually providing what they promised they would provide? The service that's up, okay? So that's the most important concept here, is that availability and reliability of the system are what we can use as the foundation for then assessing this inverted arrow here. So we're going to go ahead and say, what solves customer happiness and customer trust, end user happiness, end user trust, or say you just have an API, a collection of different microservices that are all consuming each other. Essentially, what promotes reliable infrastructural decisions and infrastructural interactions. Okay, so let's go ahead and go to this. So this is called the Dickerson Hierarchy of product development, and this is what you get when you think about what promotes customer trust and reliability, end user trust and reliability, service consumption trust and reliability. You start with monitoring. This is the most foundational aspect. If you're going to build a system that you think is really going to do well, you're not just building it for fun, you're building it to make money, or you're building it to facilitate other systems, and you want it to be highly available and highly reliable. These are your considerations. And just like Maslow's hierarchy of needs for human beings, the most fundamental one is monitoring. So this is things like monitoring the requests, the number of actual requests, the number of requests that get had served, what the actual latency of those requests were, whether the data that those requests might be serving up is actually accurate data. These are all things that basically are foundational indicators of availability and health metrics of a given system. So monitoring is the most important thing, because what stems from monitoring is incident response. So you have to realize that these are, when you're building a software system, or when you're building just a complex, any kind of complex system, essentially, is going to have things break. That's just the nature of what it is. And so what the question is, we're going to accept that things are going to break. We're not going to like it, but we're going to accept that things are going to break, and we're going to do everything we can to minimize the number of breaks that occur. So instead of pretending like we're going to have 100% uptime and basically bleeding money out your ears for 100% uptime, you're going to go ahead and accept risk and basically go ahead and try to mitigate that risk as best you can. And you do that with incident response. So again, when you're considering building a reliable system, the first thing that comes is what is our monitoring strategy for the system? Second thing is, how are we going to respond to the outages that will occur? And these are things like metrics you might capture, like your mean time to failure of a system. So once a system is deployed, what is the average time it takes before some kind of issue happens with the system? Whether that be some faulty code, a memory leak, a null reference pointer, just a whole bunch of things. Whatever can potentially go wrong is going to go wrong at some point at scale. And so you have mean time to failure. You have mean time to recovery. That's okay. Once there's a failure that occurs, how fast can someone get on that failure and fix it? And you capture these metrics. And when you're able to capture these metrics, you're actually able to iteratively improve on these things. So then you have things like an outage playbook and training. So, okay, given that I have now captured metrics for mean time to failure and mean time to response, how do I go ahead and actually iterate on these, learn from these failures, and allow my team to essentially mitigate the frequency of their occurrence, the blast radius, which is essentially how many other services it might affect if a service goes out or down. And then that's with things with like an outage playbook. So like, okay, if A, B, and C happens, do D, C, and E. Essentially, and that's just like a series of sequential steps for a number of potential incidents that might occur. Keep track the incidents that occur, and then there's things like from one of site reliability engineering practices. Is one of them is this thing called the Wheel of Misfortune, where essentially you play a game with your team where it's like, okay, this kind of outage scenario has occurred. What do? You know what I mean? Turns out maybe this person isn't on call, but person A isn't on call, but person B is available. Okay, so person B, what do you do? How do you solve this problem? And when do you escalate to ask for assistance from other parts of your team? All right, so and part of that goes into this concept of blameless postmortems and root cause analysis. So when you find a problem that actually went wrong with your software system, don't just patch it, okay? Because it's gonna maybe patch it and just push it back quick, but don't just like accept that, okay? You have to go and find the actual foundational cause for the error in your system, because otherwise you're just gonna be patching on patching on patching, and it's just gonna get out of control, and it's not actually gonna solve the real problem. And the real problem with that is that just adds up. That's technical debt that you're accumulating, and that just gets out of control when you keep patching and patching and patching. So root cause analysis, we'll start with that, RCA for short, is just find the foundational issue with the problem. Don't skirt around it. And blameless postmortems is part of that sort of culture of embracing failure, of embracing that, yes, these systems will go down at some point. There's lots of people working on them. We're working on a very large scale. Hardware failures happen. Code bugs happen. All these things happen. Let's embrace that and be okay with that. And then we're going to go ahead and not point fingers when things go wrong, but instead focus on, okay, if person A pressed button B, then maybe it's not person A's fault that they pressed button B. It's the fact that button B shouldn't have been there in the first place. So it's things like that, and being able to consider that and move forward like that is very important. So on top, next thing after you have these kind of foundational pieces in part, we're working up our pyramid esque structure here. So we have testing and release procedures. So this is your typical CI/CD pipelines, things like static code analysis, things like dynamic analysis, things like, okay, a couple of manual check gates, potentially, ideally not. Things like security verification tests that run to ensure the environment doesn't have any, the upstream environment has no configuration drift on the servers, so you're not deploying into some unknown space. You know exactly what your deployments are. And again, this is where previously with Terraform, we talked about immutable infrastructure, and this is where immutable infrastructure really comes into play here, is being able to deploy something and know exactly what you're getting every single time. You don't have to write different Ansible runbooks for each different configuration of your system state. You can actually just, create, say, Packer machine images and deploy those Packer machine images with Terraform, and then have the application baked into those packages, or not packages, baked into that image, and you have this much cleaner, immutable way of deploying and deprovisioning your infrastructure. So that's a good goal to have as well. So after that, you have things like capacity planning. So now we have good testing and release procedures in place. Now we have to consider, okay, are we going to have to scale up various aspects of the system to deal with various we'll say volatility in the number of requests that we're going to have. So say you have requests coming in, say you're, for example, you're an e-commerce shop and Black Friday comes up. You're probably going to have to scale up a number of your servers in order to accommodate the extra traffic that's going to come onto your site. So that's planned. That's an example of basically capacity planning, but that is something you can easily foresee. Another thing is like, okay, so how about things you can't foresee? Say you just have some random spike in traffic for whatever reason. Say your business or whatnot is going viral on social media for whatever reason, and you're getting a huge influx of traffic, unexpected traffic. How do you handle that situation, right? Do you have a set of alerts that actually allow for auto scaling in terms of, okay, I have a series of distributed virtual machines that are each running applications that are microservices, and how do I actually scale these? Say there's a load balancer sitting in front of each of them, distributing the traffic between, say, we'll imagine we have 6 virtual machines and 3 load balancers. We'll say that each of the load balancers is assigned to 2 virtual machines, right? And then this can handle our usual traffic, but again, we have this substantially more traffic. So how do we handle that? Maybe we have some alerts based on the number of requests that are coming in that'll actually horizontally scale the amount of virtual machines behind those load balancers, or there's a million different ways you could do it. But that's an example of capacity planning. So then we get up to actually the product itself. So development, velocity, issue backlog, and again, maintaining a good balance between developing new features and fixing the root cause problems that exist in the system that is being deployed or it has been deployed. So maintaining again that velocity to be able to keep up with your competitors, but also we're maintaining that reliability to be able to promote customer trust and enjoyment of your system, right? Because the instant that a customer doesn't trust your system, or the instant that your system is features of your system aren't as available as they should be, the customer is going to go to your competitors. Okay, and then finally you have the product itself, which is again the kind of accumulation of all these base components. And again, this is the foundational elements of building highly reliable production systems. And these are the kind of ways you should consider them in as well. You don't just jump into development unless you're like, this is contextual, but unless you're like a startup that's just trying to race to market, don't jump into development, right? Consider for a second, all right, how are we going to monitor our infrastructure, right? Are we going to use Kubernetes? And are we going to have something like Istio, which is a proxy sidecar that can actually monitor the requests and say centralized configuration for various circuit breaker patterns or whatnot to facilitate a much more observable system and a much more resilient system. So yeah, these are all just things you got to think about. Let's see. I don't know how to go to slides. There we go. Okay. And yes, so this is what it looks like when you lay out these chunks of the pyramid over the software delivery lifecycle pipeline. So again, remember, we have ideation, we have product managers, we have development, so we have continuous translation of English into logic, we have continuous integration of logic into existing logic, or moving new parts of the code into existing parts of the code, we have quality analysis of that code, we have the push of that code to a production environment, and then we have production operations, alerting, monitoring, essentially maintaining the reliability and availability and maintaining your promise and promoting trust with your customers. And so when we see monitoring spans that whole development, testing, QA, push to production, and production operations. You want to be monitoring things like, okay, what is the velocity? How quickly am I moving things, feature requests out of the backlog? How quickly am I moving repair items out of the backlog? And then the backlog is just it's a word for the kind of where you store the features that have to be made and whatnot, just like task items. And then we have things like incident response, which again is spanning that whole thing. So when things go wrong, things will go wrong. When things go wrong, how do we handle it? That spans everything. You want the dev team to be involved with that. You want the testing and QA team to be involved with that. And you want the operations team, security team, they should all be involved with that. There should be, depending on the size of the incident, they all should sit down and learn from that incident. And you should review things like how to handle that incident. Because if that incident occurs too much, your customers go away. And then when they go away, you go away because the business no longer exists. So then again, spanning that whole thing again when we discuss the integration of teams around incident response and around understanding what the real goal of your system is, which is high availability and reliability and promoting trust and love with your customers. So again, the blameless postmortems and root cause analysis spans that whole thing as well. Okay, there should not be emphasis on quick fixes. Quick fixes are great in the short term, but in the long term, they're going to eat you alive. It's the same thing as with making money. There's a lot of like little hacks you can do to make money, but in the long term, you're going to eat shit. That's really what happens. And then same with systems. There's a lot of little hacks that you have, but if you don't do proper root cause analysis, then you're not going to effectively continue to build what you need to build. All right, and now we've got testing and release procedures. Again, you see this kind of spans the development, testing, and QA section here. And then capacity planning also spans the development, testing, and push to production as well. That could also probably work with product operations. This was kind of an ad hoc thing here. I just tried to grab that hierarchy, the Dickerson hierarchy, and just invert it onto this pipeline here. But yeah, I think it works. And then development, obviously we have development corresponds with development strictly. That's kind of a separate thing. And then product management corresponds directly with the product. So again, if we go back to that previous slide, we see again, this is how it looks. These are the considerations you should have, starting at the bottom, working your way up. And then this is how they look if you line them up over the software delivery lifecycle pipeline, from ideation to happy, trusting customers that are experiencing a fantastic, reliable service. So, all right, guys, thank you very much for watching. I hope you enjoyed this. I hope you learned a thing or two from this. These are important things, things to take away, I think, specifically. I know we are development focused here on the channel. We're doing a little bit more with operations recently, but essentially, things to take away. Don't just go for the quick fix. Maybe go for the quick fix initially, push to production, but always stick with it and find the root cause of the problem. Accept that failure is a thing that is going to happen with your system, and when you're able to do that, you're able to move into things like not pointing fingers at people and actually coming together to understand how you can more quickly respond to these incidents with metrics like mean time to failure, mean time to failure in a given system, mean time to response. In terms of how quickly you can fix the system, and yeah, and observability. Observability is really just the number one. Like you want to understand, you want diagnostics on the entire stack, going from OS boot diagnostics to guest diagnostics to request diagnostics to latency diagnostics, data durability diagnostics, and you want all of these things in real time, and you want them to be distributed to your entire team, because one thing that can bring together entire teams that are traditionally siloed is the idea of what the customers want and what ultimately results in them keeping their jobs, but what the customers want, and that's a reliable service that they enjoy. So yeah, thank you guys very much for watching. If you enjoyed this video, thumbs up would be great. Please subscribe, and I'll see you guys in the next one. Have a good night.